Welcome to the lecture series for the course Microcontrollers and Real-Time System. So here it is a practice of measuring the brightness of a light using Arduino. A small project work is going to be discussed. So here we use an analog sensor. Analog and digital signals are used to transmit information, usually through electric signals. In both of these technologies, the information like audio, video is transformed into electric signals. The difference between this analog and digital technology is that in analog technology, information is translated into electric pulses of continuous amplitude, but in digital technology, the translation of information is in binary format, that is 0 or 1, where each bit is representative of two discrete amplitudes. Here we will try to use a sensor. The sensor plays an important role to collect analog data. So we can read them because it converts the analog data into digital data. The sensor we use here is called photoresistor. So it is also called light dependent resistor or LDR. The sensor is a sensor whose resistance value decreases or increases with the brightness with the amount of light. The circuit to be constructed, the brightness of this LED will be changed according to the brightness of the environment. If the surroundings are dark, the LED will also become darker. If the surroundings are brighter, then the LED will also be brighter. The circuit configuration for measuring the brightness of light is shown. So we need two resistors, one 2K ohms and 220 ohms. The circuit, it works like this. The current begins to flow from the red bar at the bottom of the Arduino board. The current goes through the photoresistor and a 2K ohm resistor to the ground and the Arduino board. The measured amount of light is sent to the pin number 4. Then, according to the amount of light, the current flows from the digital pin number 10 with output mode and goes to the LED. Then at this time, it adjusts the LED brightness by the amount of light measured while passing through the LED. So here is the sketch for light measuring circuit. First, the digital pin number 10 in the setup function is set to the output mode. This is because the circuit is configured to turn on and adjust the LED on the digital pin number 10. Then we use serial.begin. This is a stage to prepare for final serial communication. This is needed because serial communication is essential for the sensor to measure the amount of light and transmit data to the PC. So 9600 means serial communication speed at 9600 bits per second. The serial communication is the process of sending data one bit at a time sequentially. If you use serial print hello world, then you can print the text hello world to the serial console at brightness equal to this sample. So the serial begin 9600 does not actually print anything, rather it initializes the serial connection at 9600 bits per second. Both sides of the serial communication, the Arduino and your computer, need to be set to use the same serial connection speed. If there is a mismatch, the system thinks the speed is, then the data will be a garbage data. So both sending system and the receiving system need to have the same speed. So now we will move on to the loop function. The Arduino command to read analog values, analog read. When we try to configure the circuit, we have to set the analog read to A4 because the sensor is connected to the analog input A4 pin. To make the digital pin number 10 to turn the LED on, we have to use analog write command. It is different from the digital write, which just has high for light on or low for light off. Analog write can be used to set the brightness of the LED according to the brightness of the light in the environment. So here the value is divided by 4 because the analog pin reads the value by using 10 bits, but the digital pin expresses the value by 8 bit. So the number that can be represented by 10 bits is 1024, which is 2 to the power of 10, but the number that can be represented by 8 bit is 256, which is 4 times the difference of 2 to the power of 8. So the data value read from the analog pin is divided by 4 and used as a digital value. So here we show how to display the measured values for using the monitor. So this can be done with serial.print and serial.print line function. We have to set the delay to make the measurement every 10 milliseconds. So after writing the sketch, we have to compile and apply it in Arduino board. You can see the measuring of brightness of the light and the output result in the serial monitor, which are continuous. So you can see the LED brightness and the serial monitor value also changes. So thank you.